So what I want to do now is work through some further integration of inverse trig questions that are not in your booklet, that are a little bit harder, but we need to be able to work through. So let's have a look at the one in front of us here. So what we're going to be looking at is integrating 6 over 49 plus 25x squared dx. So we need to be, I guess, looking at the format of these, and if it wasn't in the inverse trig question section, we need to be able to recognise that it is. So when we look at that, we go, well, there's no other way we could do it. A lot of you would be wanting to try logs and that sort of thing, but we can't do that. So we need to recognise that it's going to be a tan inverse, okay, like up here. And that's the format that that question takes. So we need to get it, so it looks like that format, pop it over to here, and we're nearly done. Okay, so what we can see is, let's write the 49 as 7 squared, and let's write the 25x squared as the function 5 of x all squared. Now what I did was take the 6 out the front. Okay, my dx is still there because it's with respect to x. And then when we're looking at that tan question, if I go back up here again, the top line has the derivative of the function. Now our function is 5x, so the derivative of 5x is 5. So the 6 is already there. I put a 5 out the front, so I also need to divide by the 5. So the 5 and the 5 would cancel, and the 6 would be there, which is what it already is. So in this case, it's a balanced equation. We haven't changed it. It's all good to go. So from this format, we can pop it into our tan question, or tan solution, noting that it's 1 over a, tan inverse f of x over a. So the 6/5 stays there. 1 over a, because a is 7, tan inverse of the function 5 of x over a. A is 7 plus c, and that's our solution. You could times that and get 6 over 35. We'll just leave it like that. Okay, let's look at another one. Okay, now what we're going to do is we're going to integrate e to the x over 1 plus 2x dx. Again, this one I think is probably a tricky one because it doesn't look first up like it's going to be a tan. But if we rewrite it like this, the 1's a 1 squared, the e to the 2x is e to the x squared, the derivative of e to the x is e to the x. So it's already perfectly in the form of inverse tan. So what we can do is write it as, well, 1 over 1, or 1 over a, and you don't even need this bit, tan inverse e to the x over a plus c, get rid of the bottom ones, and we've got inverse tan e to the x plus c. Okay, let's do another one. Okay, these are in your OneNote as well, guys. Okay, so this one's a little bit harder. We need to think a little bit about this. It says differentiate x sine inverse of x. Okay, so that's step 1. And hence, so remember what hence means? Using the information that we have before, find the primitive of sine inverse of x. Now I wouldn't think too much about the second part yet. Let's differentiate this and see where we go. So we're going to be using the product rule. So we've got a u and we've got a v. So this is a little bit from last lesson. Okay, so u is x, v is sine inverse of x. So u dash is 1 and v dash, we're going to go back to our HSC formula sheet and see what we end up with v dash and write that in. So go and do that. So we're going to end up with 1 over the square root of 1 minus x squared. Okay, so using our product rule, again, use that off the HSC formula sheet. Okay, so we're going to have dy dx is vu dash plus our u v dash. Or if you've written it out right, you're going to be crossing them over along that way. So vu dash is sine inverse of x plus uv dash is x all over 1 minus x squared. Okay, so let's see what we know. We know that if this is our y, I'll pop that as y equals, we differentiate this and we get this. So therefore, if we integrated this, we'd get this. Let's work through the answer. Now let me talk through it. So the bit where I was talking about this and this, let's do it. So if I integrate my derivative here and write the integral of sine inverse x plus x over 1 minus x squared dx, that's going to be equal to my original question. Okay, so remember integration and differentiation are the opposite. Okay. So I'm just going to split that whole integration into two parts. So if I'm integrating a whole, I can integrate each section separately. So that would be written as this integration of this part here with respect to x, plus the integration of the second part there with respect to x. And it still equals x sine inverse x. Now remember what we're trying to find here, if we go back up here, is the hence part. Hence, find a primitive of sine inverse x. So we want to find what the integral of sine inverse x is. So if we look down here, we have an equation here, okay? And this is the part we want to find, the sine inverse x. So if I take this part from both sides, I'm going to have an equation that works for me. So the integral of sine inverse x, or the primitive, is equal to this x sine inverse x, take away the integral of x over 1 minus x squared x. Now we have to work this part out. We know this bit. If we work this bit out, we've got our answer. Now, because we're in an inverse trig topic, chances are you're going to look at that and go, oh, that's a sine or a cosine. It is not, because if that's a squared and that's f of x squared, the derivative should be 1, and we have an x. That's not going to work. This is a reverse chain rule question back from year 11. So, over to the side. Let's reverse chain rule it. Okay, so that's what we want to integrate, or reverse chain rule. So I've just brought the fraction up to the top as a minus a half. And remember what we did to work it out last year? Okay, integration and differentiation were the opposite. So I said, well, let's just look at this part in the brackets, add 1 to the index. I've written it down here, and find the derivative of it. So the derivative of 1 minus x squared to the half, sorry, my pen's a bit messy there, is, whoops, sorry, bring down the power, I've got a half, 1 minus x squared to the minus a half, times the derivative inside, which is minus 2x. The 2's cancel. I've got a minus x out the front. I might just write that over there, which is minus x. And that's going to be over the top of the square root of 1 minus x squared. So if we differentiate this, we get that as our answer. So going backwards, if I integrate my answer, which I've written down here, I get my original question. Okay, so that's that relationship that we looked at before. But what we want to find is the integral of that one there, which looks very similar to here, except for a minus. So if I pop a minus in front of my answer over here, I've got what I want. So the integral of x over 1 minus x squared is minus 1 minus x squared to the half. So I'm going to pop that back into my sum over here, and I'm just about there. I love this question. So the integral of sine inverse x is our x sine inverse of x minus the minus. I popped it a double in there because I know some of you are going to forget that, which is a plus. 1 minus x squared to the half plus c. And there's our solution. And I've double checked that with an online calculator, and we're right.